How do I name a circle? That's what I got to talk about first. Because when we've done polygons this year, you guys just go by the vertices, right? Whatever the vertices are. Problem. Circle. I got no vertices, right? Circle's got no vertices, so how do I name it? Pretty easy. You name it by its center point. All right, a circle is named by its center. Okay, so this circle here, hey, my name is Circle C because that's my center, Circle C. So I always name it by its center. All right, you'll notice 3 parts I've drawn inside the circle. I'm going to say you are familiar with 2 out of those 3 parts. First part, diameter. Diameter. That's a segment that goes through the center, and the endpoints are on the circle. You guys have heard the diameter before, right? Okay, it's got to go through the center, and the endpoints are on the circle. I cut the center in half. I have what's called a radius. If you have 2 in the same circle, they're called radii. That's the plural, radii of radius. That is from the center to a point on the circle. It's half the diameter length. No big deal. Now here's where I think we're going to start getting into some new vocab. Chord? Chord? No? Okay. What a chord? It's a segment, but the endpoints are on the circle. Okay. A chord is a segment in the circle, but the endpoints of that segment have to be on the circle. So, question right away. Diameter. Could diameter be considered a chord? Yes. The segments are on the segment. The endpoints are on the circle. In fact, here you go. Little fact to impress your friends with later. Diameter, longest chord in the circle. You will not find a longer chord than the diameter. Okay, that's the longest chord in a circle, is the diameter. All right, questions? All right, kind of going with what this whole theme of the year has been, being congruent to each other. When are 2 circles congruent? Ooh, well, you can't do side, angle, side, right? What's up, Quincy?
On the diameter.
Even less. Cut it in half. All I need are the radii. If radii are congruent, okay? So when are 2 circles congruent? When their radii are congruent. When the radii are congruent. So one circle has a radius of 5 inches, the other circle has a radius of 5 inches, they're congruent. Okay, when the radii are congruent. You think 2 circles can be similar?
Are they always similar?
All circles are similar, correct. Yes, all circles are similar. And the reason why? Remember, when 2 figures are similar, aren't there corresponding parts in the same ratio? Okay, well, hey, let's say I draw a circle here that's got a radius of 6, and this has a radius of 2. The ratio is 6 to 2, right? It's always going to be 6 to 2. I draw another radius. What's the length of that one? Also 6. What's the length? I draw another radius here, also length of? It's always 6 to 2. Okay, so all circles are similar. Concentric circles. You guys have seen this in real life. You just never knew they were called concentric, maybe. Circles that share the same center. Here we go. Could be more, but here are 2 circles that share the same center.
It also says they're coplanar, so that one of them can't be like sideways, right?
Correct. Anywhere you've seen this in life?
Gears.
What, gears? Yep.
Clocks.
Clocks.
Dartboards.
Dartboards, yeah.
Targets.
Targets, there you go. I was waiting for that one. Yep, targets actually are multiple concentric circles, right? Yep. Anything else? We had donuts in first period.
I don't think that counts. 'Cause I'm not gonna.
Tires. All right, so all concentric. Inscribed, inscribed. What's it mean for a polygon to be inscribed in a circle? Okay, all right, it's inside, but I would just warn you, be careful with that. Yes, the polygon would be inside if it's inscribed, but be careful, take a look. That polygon's not inscribed. But wait, it's inside the circle. Ooh, wait, not only does it have to be inside the circle, ready? But the vertices of the polygon have to be touching the circle. All right, so yes, when we say a polygon is inscribed in a circle, it is inside, but the vertices must be touching. So the polygon is inscribed. What can I say about the circle? The circle is circumscribed around the polygon. All right, so circumscribed. Sorry. So circumscribed outside. Okay, outside. So we say the polygon is inscribed, the circle is circumscribed. All good?
So would that just look like if that's a diamond inside a circle, then it would be a circle inside of a diamond?
Say that one more time. If the circle was inside?
If with the inscribed, what's circumscribed?
Circumscribed is talking about the figure on the outside. Inscribed is talking about the figure on the inside.
So, but it'd be the same diagram.
Correct. For circumscribed and inscribed in this case, yes. Yep. Same diagram. My quadrilateral is inscribed. The circle is circumscribed around the square. Wow, a lot of new vocab already, huh? All right, here's what I needed to get to today, circumference. All righty. Every figure has a perimeter. All right, I guess I'll take a phone call. Yeah, no, just the colors out there. All right, thank you. Yeah, all right, thanks. Yeah, bye-bye. All right, sorry guys. Every figure has a perimeter. I just add up all the sides. But the circle don't have any sides. So I can't really say perimeter. Instead, I would refer to it as the circumference. The distance around the circle. You guys have heard of that term before, circumference, maybe even seen these formulas before. What I would like you to do is just choose one formula now and stick with it. In class, I will be using C equals pi d. Pi, again, is that button right above the division sign on your calculator, 3.14, da-da-da-da-da. D stands for what in this case? Diameter length. Or you can use the other version. Circumference equals 2 pi r. R for radius length. Please decide and stick with it. Okay, we can use pi d or 2 pi r. That is a formula I will not give you on any test or quiz we take in this unit. All right, circumference is not a formula I will give you. Also, if you want any devices to remember, circumference equals pi d, coffee equals pi donuts. Coffee equals pi donuts. And then I was going to steal this, but this is, I'll give credit to a student in my first period class for C equals 2 pi r. Twinkle, twinkle, little star, C equals 2 pi r. That's what she told me first period. Never heard of that. today until now. Twinkle, twinkle, little star, C equals 2 pi r. There you go. All right, so number one, very basic at number one. Find the circumference. Leave your answer in terms of pi. I got to talk about that at the end. So for class purposes, I'm always going to use circumference equals pi d for class purposes. Again, you choose which one you want to use and keep using the same thing. So it looks like the radius is 16. I'm going to double it to get the diameter. So the diameter is 32. Now let's talk. In terms of pi means I need to see a pi in your answer. Don't go to your calculator and do 32 times pi. I need to see pi in your answer when it says in terms of pi. And just so you know, some mathematical etiquette, we usually don't say pi 32. We don't say pi 32. We say the number first. So that's how I would like it written. 32 pi. Okay, so the circumference is 32 pi. And again, it's in terms of pi. I have pi in my answer. Any issues? Anybody at home, any issues? All right, let's step it up a little bit more now. Now in number two, give me the diameter and radius if you know the circumference already. It's 106.4 millimeters. All right, going to keep with my formula, pi d. I'm going to plug 106.4 in for the circumference C. And it looks like, according to my formula I'm going to use, I can find diameter. How? What do you want to do on both sides here to find my diameter? What can I do on both sides? I got the cheat sheet ready to go. Here we go. Anthony, what can I do on both sides to find the diameter?
Divide both sides by pi.
Good job. I'm going to divide both sides by pi. And you go right to your calculator again. 106.4 divided by the pi button right above the division sign, above the arrow there. Second arrow. Round to the nearest hundredth, 33.87 millimeters. And now to find the radius, yes, I would divide by 2, but I'm going to give you a little tip. I would prefer you divide the non-rounded answer by 2. That's a more exact answer. All right, than dividing a rounded answer by 2. So go to back to your calculator, take your calculator answer, divide that diameter by 2, and then round that. That's a little bit more exact. 16.93. Millimeters. All right, I need to ask, before I move on to the next problem, I need to ask a question of you guys. Did anybody use circumference equals 2 pi r and divide both sides by 2 pi and did not get our r value? Please tell me up front. I know what the problem is and it's not an issue. Did that happen to anybody? You divided both sides by 2 pi but didn't get 16.93? Anybody at home? Because I know what the problem is. What's up?
I just have a question.
Yep.
Because my calculator is still in a degree mode.
That's-
Does it change anything?
It's not going to matter because this has nothing to do with degrees at all. So it's not going to matter. Yep. All good? All right. If nobody had that issue, then I'm not going to talk about it and confuse you. So I'm going to move on. 3, a square with side length 9 inches. Oh, there's our new vocab word, is inscribed. So I have a square inside the circle, and I got to make sure all 4 vertices are touching the circle. Ooh, hey, there you go. And it's in circle J. What do I know about J then? Circle J. Begins with C, ends in enter. Center. Good job, Mae. That's the center of the circle. Yep. That's J. And what do I know? Each side length is 9 inches. Find the exact circumference. Why did I put the word exact there? I'll explain in a minute. Ooh, a little more challenging now, huh, honors kids? I'm going to ask you for the circumference. So what's the only value I need to know if I use this formula C equals pi d? What's the only value I need to know to find the circumference? Diameter. Ooh, okay, help. Need a little help now. How can I find the diameter of this circle? Well, let's take a look here. Diameter. That's a diameter, right? Oh, let me actually go through the center. That's a diameter. Kinda. There you go. Ooh, I know the part inside the square is 9, right? But I don't know about these little pieces on the outside. I have no idea. All right. I don't think that diameter is going to work. Where else could I? Maybe, how about this diameter? Same problem, right? I know the inside's 9. Darn it! Is there a diameter I can draw in that's actually going to help me? Hannah? Draw one of the diagonals of the square now. Everyone see that a diagonal of the square is also a diagonal of the square is also the diameter of the circle. That was a mouthful. Okay, great. How are you going to help me find it? Pythag? Whoa. Before you start belting out Pythag, you better be able to prove some stuff. Pythag, I need a right triangle. What do you got? Where is it? It's a square. What do I know about the angles? Okay. Wait a second. I'm still not sold on Pythag yet. Don't I need at least another side? All sides are 9 because it's a square. Yes. All right. I got you. You sold me now. So I can see where Pythag is coming into play now. So 9 squared plus 9 squared will be equal to my diameter length squared. Here we go. 81 plus 81 is equal to d squared. 162 equals d squared. And now let me go back to the directions. Exact circumference, meaning no decimals. Leave it in fractions or radical form. All right, exact circumference, no decimals. And in terms of pi. All right, no decimals. So what do you think I'm going to ask you to do as we take the square root of 162? Simplify, break it down, yes. Because I do not want the decimal version of the square root of 162. Anybody find the biggest perfect square that goes into 162? Hint, we already found it.
81.
81, yep, up above. How many times?
2.
Twice. So the diameter will be? Square root of 81 is? 9. And then the square root of 2 comes down for the ride. There you go. There's the diameter. So now we can solve for circumference. Circumference equals pi times the diameter we just found, 9 radical 2. But we already talked. We don't say pi 9 radical 2 when we talk math. We'll say 9 radical 2 pi, just to, hey, make sure that pi is clearly outside the radical. And then what are my units here? Inches. So that is exact circumference, 9 radical 2 pi inches. No decimals, no decimals.
I think just have to be leave it in terms of pi.
What's that?
I just have to be leave it in terms of pi.
It is in terms of pi,
Oh,
right? It's got a pi. In terms of pi means you have pi in your answer. You didn't go to your calculator and multiply 9 radical 2 by pi. You just left it
no,
pi.
I thought you said that we couldn't do that.
No, and that's what you, for exact circumference, yes. Because if you multiplied that answer by pi, you're going to get this long decimal in your calculator, which is an exact. All right, this is as exact as we can get. Other questions? All right, why don't you say we hit up a graph here and talk? All right, I'm going to give you the center is Q, and then I'm going to give you another point, R, which the circle passes through. Okay, you guys have had an opportunity to graph it. When I connect QR, does anybody know what that is? When I connect Q to R, it's the radius, isn't it? And if you guys at home too don't see that, here you go. Let me give you a little visual here. Oh boy, there. It's been a while. Oh boy, I'm gonna have to knock off the rust here. Oh, look at that. Remember that thing called the compass? There's the center. R is a point that the circle is going through. Everyone see how that's the radius now? Yep. All right, so go ahead. We got to use distance because I'm not looking for radius length. I'm looking for the diameter length. So we're going to have to use distance or Pythagorean theorem, whatever you use or have been using all year. All right, let's see what you guys got here. We got 4 squared under one, and then we got 3 squared under the other. Remember, you take the square root at the very end. 16 plus 9. So we're going to take the square root of 25, or 5. And then if I want to find the diameter, that's radius. Remember, that's the radius length. If I need to find diameter, I can just take 5, double it, and it's going to be 10 units long. All righty. Questions from you guys there? And I think I'm going to let you do 5 on your own. That is a rectangle. That is a rectangle, everybody. Leave your answer in terms of pi. Yes.
Instead of writing distance while solving the distance formula, could you put an R because I thought it was diameter for a second, and then I realized it was.
Oh yeah, that's fine. Yep. Mm-hmm.
The abbreviation for circumference is just C, right?
Say that one more time.
The abbreviation for circumference is just C, right?
C equals, and then whatever one of the two you're going to use. Yes. I think many of you are probably drawing in another diagonal of the rectangle this time, of the rectangle. That also acts as the diameter of the circle, doing a little Pythagorean theorem. There is no reason to break down this radical. I hope not. Everyone's getting 10 for the diagonal length there, or the diameter length, more importantly. So pi d, circumference equals pi times 10. And just make sure we rewrite it professionally. 10 pi inches for the circumference. Okay, we still have about 12 minutes left. Look, you guys at home want to sign off and start the homework, feel free. If you want to stretch, grab a drink, grab something to eat, go right ahead too. I will see you guys on Monday. All right, take care.